Hello and welcome to our presentation on evolving traceability. This is based on an IEEE Software paper. My name is Wohlrab and my co-authors are Pelliccione, Ali Shahrokni and Eric Knauss. And here we are concerned with the topic of traceability, so the ability to create and use links between artifacts. And those artifacts could be architecture descriptions, requirements, source code, models, or documents of different kinds. And we collaborated with the Automotive Supplier Zenuity that was just about to start setting up traceability strategies and thinking about how they can change over time. A lot of the literature actually assumes that traceability strategies can just be defined at the beginning and then followed, or there are some that say that it is an iterative process, but there's not much guidance on the topic, and that's why this was an interesting area to explore in this study. We collaborated with Zenuity over a period of 3 years and saw how they conducted traceability strategizing. And our main questions here were how companies establish and evolve their traceability strategies, and also how we can support practitioners better in the future with appropriate tooling. And in the paper we have a running example that illustrates this topic of traceability, and there we have a collision avoidance system with a number of artifacts. For instance, safety artifacts with hazards and hazardous events that are created and traced to each other. We also have an area of function definition with a safety goal that is traced to both the hazardous event and an interface at a functional level. And we have an area for design artifacts with different components that produce and receive signals. And these signals in turn are also traced to the functional interface, but not with a direct trace link, but with a mapping object, which is a separate artifact that decouples these two artifacts and creates a link between them. And already in this small example, you can see that there is a number of artifacts that are relevant and quite many trace links. And overall, we found that there were more than 200,000 trace links in place. And of course, they changed dynamically and new trace links had to be created and used over time. And one important factor here is that some artifacts play a role for not just one team, but are important across team borders. And we call them living boundary objects and define that concept in this paper. These living boundary objects are indicated in blue here and are used to create a common understanding of the system, but at the same time, different stakeholders can use them for different information needs and purposes. And it's extra important to trace living boundary objects and maintain that traceability over time. Besides this instance level, we are also concerned with the traceability strategy level. So that's one abstraction level higher up, where we're reasoning about artifact types and trace link types in a traceability information model. And we're also reasoning about processes with different stages like prototype development, and maintenance. And of course, tooling concerns and the configurations are also of central importance and something that might change over time. Because we observed that change can occur both on the traceability strategy level, because we're transitioning between different process stages and these processes might change, tooling might change, and also the needs that should be captured in the traceability information model are changing. And that affects the instance level and vice versa. We're exploring these dynamics and explaining in this paper how technology, business, organizational, and process needs motivate the need for changing and evolving traceability. One factor that is really important in this context is that actually different organizational groups impact how trace links are managed and changed. We saw that there are 4 categories that impact coordination mechanisms, starting with links to external artifacts like customer requirements that are very formally managed, where every change is documented and versioning is important. Then we have inter-team links within an organization, both vertical links where we bridge different levels of abstraction and horizontal links that are at the same level of abstraction. And there, for horizontal inter-team links, changes are a bit less formally managed and documented. And finally, we have intra-team links where we have a lot of flexibility, face-to-face communication, and not much formal versioning. And that really impacts how people work with these trace links. But these categories can also change over time. So we had an example of an intra-team link that was used in a component team that had two components and a signal between them. And then that signal became relevant for another component team because of architectural restructuring. And during that change, we had actually a change of categories here. So what was an intra-team link before became an inter-team link, and there we had more formal mechanisms to manage change, and also a new boundary object came up. To describe these different changes, we saw that this cycle of traceability can actually be used, that we define in this paper and present how we start with the observing phase, where we look at different instance levels and stakeholders see how the traceability strategy has been instantiated. And then this is assessed based on data quality criteria when it comes to aspects like consistency, completeness, are all trace links in place that should be in place, but also validity, do all instances conform to the information model, and aspects related to versioning. And then these points are assessed and measured, and it is identified what should be changed in the traceability strategy, but also in the instances. So we saw that sometimes new trace link types were introduced or refined, mapping objects might be created, and we had some other examples where the processes and the tooling configurations were refined. And then those design changes also have to be implemented, people have to be educated in trainings, and so on. It helps to have living boundary objects in place there because they create this common understanding even as the traceability strategy evolves. We also saw that after about a year, this company arrived at a rather mature point. So the traceability strategy didn't have to be changed as much anymore. And that is a common pattern that we saw also in related projects. And then new technology, organizational, business needs require new iterations of the cycle and a readjustment of the traceability strategy. We also present how tooling can support traceability evolution better in the future. Current tools do that to some extent, but we really saw the need to have more flexible data quality needs and be able to identify the needs for individual trace links at certain points in time. Also, the level of versioning should be more flexible, and we suggest a scale from loose to strict versioning that changes with the point of maturity and also with the particular trace links. Organizational traceability is key and the way to trace to affected stakeholders. And we also propose mechanisms for change management so that we detect when changes should happen to trace links and to the traceability strategy, and also propagate those changes and evolve models. To summarize, we saw why and how traceability should evolve with the examples of a concrete case of an automotive supplier. Our suggestion is that you should observe the fitness of traceability over time, because it's not an on-off thing, but something that dynamically changes and also the needs change. So we need to have ways to evolve it, and the findings in this paper show how that can be done. For future work, we suggest to invest in tools that support traceability evolution and flexible ways of managing traceability. Thank you very much.